Hi everybody, welcome back to Calculus. In this video, we are going to talk about something called the first derivative test. And the first derivative test helps us to decide whether a critical point is either a local maximum or a local minimum. So there's a lot of words here. Let's jump right in and then we'll break down this theorem. The first derivative test says, suppose that f is continuous over an interval I containing a critical point c. If f is differentiable over I, except possibly at point C, then f of c satisfies one of the following descriptions. First of all, if f prime changes sign from positive when x is less than c to negative when x is greater than c, then f of c is a local maximum of f. And then we have two more situations that are quite similar to those. So let's break this down a little bit. First of all, what is a critical point? Just to remind ourselves, a critical point, C, is a point where either f prime of c is equal to 0 or f prime of c does not exist. Okay, so we first, when we are using the first derivative test, have to find our critical points. Then it says if f is differentiable over this interval I, except possibly at this point c, that except possibly at point c is because we can have our derivative does not exist there, then f of c satisfies one of the following descriptions. In this first one, it says if f prime changes sign from positive when x is less than c to negative when x is greater than c, then f of c is a local maximum. So let's sketch this out a little bit. Let's call this point right here c. We have f prime is positive at first. So if f prime is positive, that means that our function is increasing. So we're increasing when we are less than c, and then once we get to c, our derivative changes to negative, which means that we are decreasing. That means that, yes, we can see that as a local max at c. In this second situation, we have c here again. F prime changes signs from negative, which means that our function is decreasing, to positive, which means that we're increasing. This does in fact look like a local minimum. And in our third case, if f prime has the same sign for x greater than and less than c, then f of c is neither a local maximum nor a local minimum of f. Usually this looks like the following. We have some sort of graph or function that looks something like this, where we have a horizontal tangent line or a critical point here at c, but obviously we do not have a local max or a local min here. So these are the three situations. So let's go ahead and jump into an example. We want to classify the local extrema of this function. When I say classify, this means is it a max or a min? Let's decide. Well, first we need to find our local extrema, or our critical point. So we need to find the derivative and set it equal to 0 in order to find these critical points, right? Because our critical points is where our derivative is equal to 0 or does not exist. In this case, we are dealing with a polynomial, so our derivative does exist everywhere. So we just want to see where our derivative is equal to 0. So my function f of x is equal to 1/3 x cubed plus x squared minus 8x. If I take the derivative of this function, I get x squared plus 2x minus 8. And I want my derivative to be equal to 0, so I set this equal to 0. And it looks like this factors pretty easily. This factors as x minus 4, plus 4 times x minus 2. And if we set this equal to 0, then obviously this gives us x equals negative 4 and x equals 2. These are the critical points, which is great. Now we have our critical points, but I don't know if these critical points have a local max or a local min at them. So we're going to use our first derivative test here, and here is how we're going to use our first derivative test. We're going to draw a number line for each one of these critical points. So here is negative 4, and then we're going to draw another one for 2. And basically, I want to see what the derivative is doing on either side of these critical points. So I'm going to pick a number, any number I would like, on each side of these points. I'm going to pick -5 and -3 here. And then I'm going to plug in these 2 points into the derivative and see if it's positive or negative. So f prime of -5 is equal to, I'm going to use this form of the derivative because it makes it really easy. I get -5 plus 4, that's -1, times -5 minus 2, which is -7. This is equal to a positive number. So I'm going to draw a little plus sign here. That means that our function is increasing, our derivative is positive, so our function is increasing here. And then f prime of -3 is equal to -3 plus 4 is 1. -3 minus 2 is -5. This is a negative number. I'm going to put a negative sign here. This means that our function is decreasing on this side of -4. And this tells us that -4, x equals -4, is a local max. Local max. Okay, what about 2? Again, we can choose any number we want to on either side, as long as they don't give any problems to our function. You know, for example, we're not dividing by 0 or anything. So I'm going to pick 1 and 3. So let's see what the derivative is doing at each of these points. F prime of 1 is equal to 1 plus 4 is 5, 1 minus 2 is -1, so this is a negative number. And f prime of 3 is equal to 3 plus 4 is 7, 3 minus 2 is -1, so this is, whoops, what? Sorry, 3 minus 2 is +1. This is positive. So we change from decreasing, right, when our derivative is negative, our function is decreasing, to increasing when our derivative is positive. So this tells me that x equals 2 is a local min. So this is all about the first derivative test. Hope you learned something. I'll see you in the next video.